Hello, ladies and gentlemen. Thank you for standing by and welcome to Visual BI's first webinar of the year. Today, we will be discussing data science in Azure, delivering end-to-end data analytics using Azure Databricks. We will be introducing the core concepts of data science and the resources in Azure to deliver a complete data science solution. During the presentation, all participants will be in listen-only mode. If you have a question during the presentation, please submit it via the Q&A portion of the screen. Simply type your question into the box and click the send button. Our presenter will address the questions at the end of the presentation, time permitting. If you don't hear an answer to your question today, don't worry, we will deliver answers to you individually after the webinar. The webinar is being recorded and a link to the replay will be sent to you via email. Presenting today are Chandler and Jawan. Chandler is the Vice President of Microsoft BI and Analytics at Visual BI Solutions. He has more than 24 years of experience in the information technology industry. Jawan is a data scientist at Visual BI Solutions, who has immense experience delivering prediction models using machine learning algorithms and optimizing data science workflow for the best use in cloud architecture. I will now turn the presentation over to the presenters.
Thank you very much, and good morning, good afternoon, or good evening, depending on where you are. My name is Chandler Stevens, and today we are excited to kick off the webinar in 2019 with a focus around data science in Microsoft Azure. Just a quick disclaimer, this presentation will outline a general product direction and should not be relied on in making any formal decisions around purchasing. The presentation itself, represents a Visual BI solution strategy, and possible developments may change. So, as mentioned, today I'm joined by Jawan, who is one of our lead data scientists at Visual BI, and we're really going to take you through a couple of different topics for today's webinar. The first is that we're going to do a quick overview of data science, kind of provide a baseline of what data science is and how it can be implemented, or what function it provides. We're also then going to turn our attention into data science within Microsoft Azure. Jawan's going to be joining and actually taking us through a demo later in the webinar. And then with the time we have remaining, we'll take questions, as mentioned, via the instant messaging chat window in the webinar. Just a little bit about us. Visual BI, we are an all-in-one partner for end-to-end BI and analytics needs. We have consulting services that range from strategic services to implementation and migrations. We have various products focusing on providing BI solutions both in the SAP and in the Microsoft platforms. We also, of course, have training around SAP implementations as well as Microsoft Power BI. And of course, we have analytics solutions that range from building out custom dashboards by line of business all the way through big data solutions. We are a Microsoft and an SAP partner, and we have a number of accreditations, as you can see at the bottom of the slide here as well. So let's kind of kick things off, and I want to bring Jawan onto the webinar, and welcome, Jawan. And just to give kind of level set our topic this morning around data science.
Yeah, thank you, Chandler. Hello, my name is Jiwon Jeon, and I'm a data scientist at Visual BI. To start with the webinar today, let's briefly review what data science is and how the Azure resources can enrich the data analytics process. So I'm going to focus on a sample of analytics using Azure Databricks Notebook for today for the better understanding. Okay, let's get into this one. With the revolution of technology, everyone knows the amount of data that we deal with every day is tremendous compared to what we used to have. So, and then the size of the data is getting bigger and bigger. And the fact that we have a wealth of information can be only a good thing, but it also requires us to think of how to maximize the value from this information to draw the best outcome for business. When data was simple and size was small, it was easier to analyze. But now, as we all know, data sizes have become very big. For example, terabyte data is kind of common now. And then the structure gets more complex. Many of you may heard about like unstructured data, whether you deal with it or not. And data can come from everywhere. So a traditional simple analysis cannot present the best understanding anymore. Instead, we need to go deeper, right? So why do these things happen? What's hidden behind the data? What kind of insights can we learn? Then here we say data science comes into play. So the data science is a need, it's no longer a want. Okay, then what is data science?
So, Jawan, thank you. I think it's important to kind of level set the topic of data science. And, one of the things I know that probably our audience has probably heard is, data is the new oil, or, data itself is now becoming very valuable for organizations who are now just trying to understand the monetization of that information. So I think obviously data science represents a gateway to those kinds of conversations. But if you could take us through kind of from your perspective, what does data science mean? What should it mean for our customers or for the listeners?
I write a definition of data science in the formal words in the below of the slide. Like data science can be defined as the study of exploring all available forms of data and employing scientific methods to extract knowledge, derive insights for actionable decision making, which sounds really weird and then long. Okay, so make it simple. If we do some research or make an action to obtain data or process it to build a model or to use it to seek any opportunities for better decision making, we call it data science. We use not only structured formats like table we used to use, but sometimes we investigate unstructured frame like a sentence or image. Many of you may heard about the image processing, those kind of words. So to figure out a hidden patterns or predict what's going to happen next, then we use statistical analysis or mathematical algorithms. And we also use machine learning techniques, which is a fancy word, to train a model iteratively to find the best option for the decision making. And when, let's say, if the size is big, and then if the algorithms that we are using are too complex to compute, then big data platforms like Azure should be of help to deliver the result. And some people might ask if data science is all about machine learning. Well, most of the time, data science uses machine learning techniques to provide solutions. Of course, machine learning it's a big part. But if I have to answer to that question, it's certainly no. As a data scientist, especially if you're working in the industry, you need to continually think about the purpose of using analytics for the organization, of course, not just to answer, to the machine learning problems. So after we have some data to study, we focus on analysis to draw the insights hidden in the chunk of data. So by doing this, we can monetize the data to make value for the business. So in terms of business, data science finds its value to meet the business goal. So modern businesses are facing rapid changes, as you all know, and then at the same time, it requires a clear data-driven decisions to deliver prompt, consistent, and also personalized responses to the individual customers or the end user, whoever it's going to be. So data scientists have to present the right offer to the right customer or to the right entity who's going to use the outcome based on the right time decision. That's what I call data science.
That's a great explanation. And so what I mentioned earlier about this discussion around data monetization, which obviously technologies around data science are invariably designed to help customers and help those organizations looking for ways to harvest the data that they have, either that they collect or that they create. And so here in this slide, we have an overview of the way we think about a journey for data monetization with respect to data science. And so there's a competitive advantage on the left, which runs from descriptive all the way to prescriptive, and as well as degree of complexity. And this effectively is a way for us to start kind of pinpointing, or at least plotting, helping customers understand where are they from a competitive advantage in terms of taking advantage of data science. And I'm going to go ahead and build out the rest of the slide. If you could kind of walk us through kind of each of the stages, just to kind of describe and help the audience understand how we think about moving from descriptive to a prescriptive opportunity.
Sure. This slide introduces the journey of data scientists to monetize data. Like you see here, by segregating the level of analysis into 3 steps from descriptive, predictive, and prescriptive. The lowest level is what we call the descriptive analytics. Here, like typical reporting or ad hoc analysis or drill down type of analysis are included in this case. This level focuses on finding the current problem. When the business requires the next level of analysis, which is predictive analytics, then data scientists needs to use some statistical models or machine learning. So we learn from the past data in like descriptive analytics to get what we might expect to happen in the future. For example, if we got to know a problem, we consider what further actions are needed to alert the current situation, like alarming system. This will lead to a simulation stage where we explore what could happen based on the previous actions, and then forecast what the trend would look like in the long term. And then precise meaning of, I would say, the predictive modeling is actually the stage here to find what will happen next if a condition or a trend is expected. But this predictive analytics does not determine what decisions we should take. Here we think about the prescriptive analytics. So it takes the prediction outcome from predictive analysis, and then it turns it into an actions that we should take next. So this is more like a optimization problem, I would say.
So when you think about the competitive advantage moving up from descriptive to prescriptive, what's the guidance we typically would give our customers in helping them sort of understand how they can move up that competitive advantage stage?
Yeah, many of our Visual BI customers pursue predictive analytics to understand what's likely to happen, and then that's pretty good. But the value of business, when you think about this one, it can be made through some optimization, like cost optimization or management, time management, this kind of thing, not just by anticipating what's next. So finding the best decisions or actions out of multiple possible outcomes from prediction is what we actually expect from data exploration. So I can give you some example, like typical process to define, to have this prescriptive analytics is to define some rules to generate recommendations. And then these rules are the decision factors or which eventually automated by iterative testing with, let's say, multiple variables using machine learning techniques, or sometimes deep learning or AI. You kind of familiar to these words like artificial intelligence. These things can be involved in this process as well.
Makes sense. So ultimately, if it's one thing to kind of look at the data and again, kind of have a predictive approach, but then actually taking action on those predictions is really where the true value comes into play for data science. So I think this next slide kind of provides a little bit of an overview of the life cycle. So oftentimes with customers, we enter into conversations around, how does one begin or how does one start their own data science initiative, or maybe starting to leverage data science capabilities. Can you kind of walk us through the overall life cycle?
Yeah, this CRISP-DM, cross-industry standard process for data mining, is an open standard process model for common approaches. It was actually used by data mining experts when they dig into data in the past. This process is having 6 phases. So it starts from the understanding business on top left to get to know what the intention of the project or the business is, and then how the analysis output is going to be used. And then we understand data, of course. In this phase, data source is identified, whether it's a single or multiple sources or something like that. And then we collect them, of course, the data. And then data preparation phase is the next one, where we clean and transform data per our intention to build models later. And usually this phase takes most of the time for the data scientists to work on any project, because we need to explore, we need to dig into the data and understand what's inside. And when we prepare the data, we go back and forth a little bit to the next modeling phase to extract the best outcome from the model. And in this modeling phase, we apply a variety of statistical algorithms or machine learning techniques, whatever you want to use, to train and then test the analysis model. And then this model is optimized in the evaluation stage to make sure that the project goal is achieved. Sometimes skip this one. This is not good. We have to evaluate the model and then see if this one really can get any value out of the data. And after this evaluation, the model is ready for deployment for the actual use and delivers the best value out of the data. So I would say the 6 high-level phases of CRISP-DM are still a good description for the analytics process, but the details need to be a little updated for our modern data science world, because this process is somewhat linear, meaning once you proceed to the next step, you don't really interact with the previous steps that much. You only do it probably in data preparation or modeling phase, but not that often. So to add the big data problems that we are having now, actually Microsoft presents a very good data science process lifecycle, which is called Team Data Science Process Lifecycle, TDSP, as you can see here. This is an alternative to CRISP-DM to handle big data, especially in dynamic and flexible transitions between the steps. So this one is actually developed for the cloud-based predictive analytics originally. And then it's more of a cyclic process than linear. As you can see here, each of the steps actively interacts with each other to accommodate the data in dynamic modeling process. In addition to this one, TDSP provides some guidance of roles and tasks and artifacts for the individuals in the project so that the teams or the customers for the project can avoid any misunderstandings. This is very important thing because many of the data science problems occur from this misunderstandings between the entities. So you have to understand each other, and then we have to make sure that everyone understands the project. And then data scientists can deploy the predictive models from this process in the production environment to build the intelligent applications. So the steps are pretty similar to what we had in CRISP-DM, with a little bit of differences in detail. So the same thing, the business understanding process starts with a business idea, which is solved with, for example, a machine learning solution. And then the project plan is generated here to proceed to data acquisition and understanding the process. And then data acquisition and understanding phases are somewhat of a combination of data understanding and preparation phases in CRISP-DM. And then this is very important phase, of course, because we are dealing with data. And then this phase focuses fact-finding about the data, including, let's say, data source, or how to configure the data, how to ingest the pipeline, how to design the environment, such as like on-prem or cloud, or how do we do that if the data is small or big, stuff like that. And then this phase also includes some data wrangling and cleaning after validating the structures and unstructured, semi-structured, or unstructured of the data. And then based on the study in this stage, the model is created and built, of course, and verified against the original business question. So the modeling stage continually communicates with the data understanding phase and the business understanding phase. You can see the arrows are coming back and forth to each other. The features for the models are selected and extracted, of course, transformed back and forth to meet the business objectives, and various models are trained and then cross-validated whenever the data is cleansed. So this is the modeling phase that data scientists probably play on. And then the models are published to production once they are proven to be a fit solution to the original business question. After scoring the model and monitoring the performance through the integration with other services, then the project enters into the customer acceptance stage, which is almost the last stage. This process is the customer sign-off point. So it confirms that the pipeline for the data integration, the model for the analysis, and the deployment in the production environment are satisfying customer objectives. So in short, the TDSP framework helps us to organize the efficient teamwork flow between the different roles and steps in the data science project, as we can see here. And then I can briefly introduce in the next slide the different roles and tasks in MS TDSP. So in this slide, as you can see, the tasks are shown in the blue squares. This is kind of typical type of data science project. So the blue squares are the tasks that to be handled by the roles, which is on the left vertical axis at different stages in the upper horizontal axis. And then it produces different artifacts, which are in the green boxes. So we can actually picture how the individuals in the project can interact with each other in each phase of TDSP, in each phase of data science project. So this conceptual diagram also, you can see that how the data scientist should perform its role, his or her roles, and then deliver the artifacts at each stage.
Yeah, what really strikes me about this slide is this very much is a team effort. When we think of the term data science and data science type work, obviously there's a subject matter expert, a data scientist who's usually involved with that. But really, when you think about the overall life cycle, you do have to have a solution architect involved to help make sure that the infrastructure and the design is solid and can be supported by the business, as well as, of course, a PM and a project lead who really kind of provide that leadership from driving the project forward, as well as making sure that the business requirements are being represented appropriately. So very much a team effort here. Clearly, the data scientist role is a critical part of this process, but other roles are also involved as well. So kind of switching gears now and talking a little bit about the Azure side of this. And I think when we look at the data science processes, how they're embedded and provisioned in the Azure environment, this particular diagram provides a sample workflow in Azure that would perform advanced analytics using big data. Azure will provide a secured integrated environment that transforms the data into actionable insights that can be used by the machine learning tools. Joanne, can you kind of step us through this conceptual architecture?
First off, let's see. It describes the process to ingest data in the ingest field from an unstructured or structured format of the original source. It's like you can see on the left, logs, files, media, or business custom applications. And then the data is introduced to the Azure environment through various services, for example, Azure Data Factory. Azure Data Factory orchestrates the data flow using a pipeline. And once ingested, data is stored in various forms based on its structure, such as, let's say, Azure Blob Storage, Azure Data Lake Storage, SQL Database, or sometimes Azure Data Warehouse and Azure Cosmos DB, which is very useful for streaming data. Like you can see here, even for the real-time data analytics, Azure platforms can capture the data continuously from any streaming source and process it near real-time. And after the data is available in Azure ecosystem, data scientists mostly involved in the preparation and modeling phase, like you can see here. Here the data is cleaned, transformed, and the models are using machine learning tools are trained and validated to reveal the insights from data. So Azure Databricks can be a good option coupled with Azure Machine Learning, like you can see under prep and train phase, as an integrated platform for the analytics process. Then the results can be stored and then used as is, or like in Azure Cosmos DB or Azure SQL Data Warehouse, or we can further transfer them to other tools to serve IoT applications or to publish reports on dashboard like Power BI, which is very useful. So this overall architecture kind of allows us to combine any data at any scale, and especially for the data scientists to build and deploy custom machine learning models. This is a very good resource to do that.
So Azure delivers the perfect resources for not only training the model, but also deploying the model. We see Azure providing an environment for data scientists to focus on the data modeling, and the ability to push this data into use, and not having to worry about the security requirements and other issues. Now, obviously, security is inherent with any Azure implementation, so we're not suggesting that security is not important, but the way Microsoft has put together the various data science resources listed on the slide allows the data science to do what they truly are designed to do, which is focusing on those problems, and then obviously having solution architects and other resources build the infrastructure around the data science models and the Azure implementation to ensure that it's compliant and will scale. Here we have 4 types of Azure services that provide various levels of advanced analytics and machine learning solutions, leveraging big data in the cloud. Juwan, if you could walk us through each one of these, I think this might be useful for setting up for our demo here momentarily.
Yeah, sure. let me just briefly introduce these services. So the first thing that I wrote here is Azure Machine Learning Studio. It's a drag and drop type visual interface. Here we can use pre-configured algorithms to build and deploy the models. This is very easy tool for a quick experiment of a model, but it's kind of limited in scalability because it's pre-configured, and then you have some limitation in customization of the data. So if you're, let's say, entry-level data scientist, or if you do not have much knowledge of programming languages, then this can be a good option to explore the data. And then the next one, Azure Machine Learning Service, is a managed cloud service for machine learning overall, where the models can be trained, deployed, and managed using Python and CLI. CLI is a common language infrastructure from Microsoft. It has many tools and packages, but it's not a compute engine. So it uses external compute engines like SQL Server or Spark, and it employs the scripting sources like Azure Notebook or Azure Databricks, or you can even use Jupyter Notebook to build a model. So it's more like an integrating platform, I would say, of different resources for machine learning modeling and then deployment inside of overall data science project. So one benefit of this machine learning service is that it tracks data preparation, modeling, and it maintains the history of all executions. So you can compare the model performances later across all iterations. So that's a good benefit for the machine learning service. And then the next one, Azure HDInsight. This is Azure's implementation of Hadoop system as a managed service with a lot of open source analytics engines. So it provides powerful computing capabilities because it's Hadoop actually for massive data. And then it provides flexibility to develop tools and monitor the models. But it requires somewhat advanced knowledge in programming. So it is useful when you want to stay in a code-based environment. But if you are not really a code type of person, this might be a little difficult to use. So Azure Databricks now comes in. This is a Apache Spark-based analytics platform where the model is developed on Notebook. So Azure Databricks allows developers or data scientists to leverage the best of OSS capabilities, like Apache Spark, so within a integrated Azure environment. So Azure Databricks makes the analytics or machine learning models a little easier to run with other analytics features using notebook-based collaborative workspace. And then it also avoids the detailed configuration compared to Azure HDInsight because it has a little bit of pre-configured features as well. So we can kind of avoid those kind of headaches that we used to have when we managing Spark or any other computing engines, which was actually one of the entry barriers of HDInsight. Here we can kind of tackle those kind of problems and then go into the analytics. So today's focus is actually to use Azure Databricks as a playground for data scientists. So I'm going to look into Azure Databricks a little more detail in the next slide. So what is the Azure Databricks then? Azure Databricks is a fast, easy, and collaborative Apache Spark-based analytics platform optimized for Azure. And then it's actually provided by Microsoft and Databricks together. So they kind of collaborate to each other. So let's think about one example to understand this. For a data science project, let's say we have a great team of data engineers who load and transform data. And then we have data scientists in it to build and test machine learning models. And also we have like business users who can present the value of the outcome. And these different roles use different tools for each purpose. And then the different skill sets for these individuals make collaboration sometimes very difficult. So that's the concept where Azure Databricks started from. Azure Databricks provides a workspace. It consists of shared notebook between these users inside of a cloud-based Azure government using single sign-on feature with Azure Active Directory, which means you can easily log in. And then you are secured to work on the same script with other people inside of in a project. And it also uses the Databricks runtime, which is a highly optimized version of Apache Spark and a serverless compute model, so it's really fast. And then this one has some kind of a semi-configured setups, so it allows us to avoid any detailed configuration work normally associated with managing Spark, which was a headache, like I mentioned before. So we can easily start to use it, and then we can easily scale and control the clusters to compute the analytic model. Now we got to know what Azure Databricks is and then why it's useful. So I'm going to go into Azure Databricks demo. Doing some data science thing with Azure Databricks. But before we go into that demo, let's check the workflow inside of Azure Databricks. So first thing is launching the workspace. So when we log into Azure Databricks into using Azure Portal, we click the button to launch the Azure Databricks workspace. And then the next one is opening the clusters. So we create a cluster, or we start an existing cluster with one click. And then the cluster has auto scaling and auto terminating features, so we can reduce resources and cost without getting bothered by manual operations. And then once the cluster is ready, then we collaborate on notebooks. So now we open a notebook for scripting the data ingestion and modeling. And here we can create custom access setting for the individuals for the specific project so that we can secure the work on the shared notebook. Now, after this one is ready, then we explore the data. So Azure Databricks Notebook provides language options for, here I say SQL, Python, Scala, and R. So we can easily mount storage for source as well, and then using these languages, and output data and can be delivered to other storages. And we can build machine learning models using the languages that you're familiar with. And the business users can see the data in live data displays under each cell in the notebook. So if we build the data science model, then we can heavily use this notebook to build the models when we build the models and then obtain any insights. So after the model's done inside of notebook, then we schedule it as a job. So when the model's ready to produce predictions, then the notebook can be run as jobs to monitor the performance as a scheduled time periodically that at a time that you want. So I'm going to go through this process inside of Azure Databricks in our demo. Now let's run a sample data science project in Azure Databricks. For the demo, I'm going to show you here. If you log into your Azure portal, this is my Azure portal, then you can see the Azure Databricks icon here. Let's click this one to launch Azure Databricks. And under your subscription, click the Azure Databricks that you're going to use. And then the first phase is to launch the workspace. So this is how you launch the workspace, and then it's going to automatically sign you in to Azure Databricks if you have the access to Azure portal. So while this one is signing in, what I'm going to do today is I'm going to build a recommender system using ALS collaborative filtering, which is alternative least square collaborative filtering. And then the source data is a movie lens data, which is very well-known template for the recommender system practice. And then I'm going to use that data to build a model. So this is the Azure Databricks website. And then the first thing here that you have to do is to create a cluster. So here you can see the clusters button. And then if you click this one, then you can find this blue button to create a cluster. So cluster is to compute your computations during the modeling. So here, when you create a cluster, you can give the name and you can set all the settings that you need for the computation. You can, of course, give this Python version to 3, and then you can set up the driver nodes based on your pricing plan or your computation requirement. And then here is the autopilot options. The first one is enabling auto scaling, meaning whenever your computation size is kind of varied, then Azure Databricks can automatically adjust to your minimum or maximum worker nodes so that you can kind of have the optimized computing environment. And then the other one is auto terminating feature. here, Azure Databricks is going to automatically terminate the cluster after a certain amount of time of inactivity, so that you can actually save some cost while you're not really using the cluster. So let's not create a new one. Let's just use whatever I created already for the webinar. So this is my cluster, and I started it already. And then this is my setting that I'm going to use. So let's say our cluster is ready to use. And then the next thing is to open the workspace. And then if you have the access to your Azure Databricks, then you will find your user account under users. And this is my account. And then to open a new notebook to play as a data scientist, you can create a notebook like this. So this is the notebook creation page. You can give the name. You can choose dominant language out of these core options: Python, Scala, SQL, and R. Although let's say you chose Python, but you can still use SQL, R, or Scala inside of the same notebook by giving some comment. So you don't really have to worry about that. And then you can choose the cluster that you want to compute for this notebook. So let's not just create a new one. I'm going to use what I created already for the webinar. So this is what I created for this recommender system. So here, I'm going to use movie lens data like I mentioned before. It has about 20 million records of ratings, and then it has 465,000 tag applications across 27,000 movies, and then they were all reviewed by 138,000 users. So the goal of this recommender system is to recommend certain movies to a particular user by predicting his or her ratings in the past. So the data is stored in my Azure Data Lake storage, and then I'm going to mount it to Azure Databricks file system to import the data. And then also I'm going to use PySpark's ML ALS recommendation module for the computation of this machine learning model. So to do this, the first thing is to import the source data. How do I do that? Since my source data is in my Azure Data Lake storage, I'm going to mount this Azure Data Lake storage to this Azure Databricks file system. To do that, actually, you have to give the access to Databricks to access to Azure Data Lake storage. Let me show you. So this is my Azure Data Lake storage, where I have my movie lens data, my folder, and my movie lens data. So for each of this file that you're going to use, the source file, you have to give the access. So if you click this access button, then you can see that Azure Databricks app has an access permission to read, write, and execution for this source data. So this one is done. And this is the code that you can run to mount your Azure Data Lake storage or whatever data source that you have to Azure Databricks file system to work on it. And then you have to give your service client ID or credentials. So you can just run this one with your account information. So I did it already for the sake of time. And whenever you need unmounted, then you can just run this simple line of code. So let's say the Azure Data Lake storage which has my source data is well mounted to this Azure Databricks file system. Then now I'm going to load the data set, the original data set, as a PySpark data frame to implement the ML ALS recommendation module. If you're familiar with RDD format, then PySpark MLlib ALS recommendation module can be your choice. So it's really up to you. In this case, I'm just using PySpark data frame. So this is the code. I'm going to download ratings, movies, and text data frame as an example. So you can run this one using this button here, or you can just simply click Control Enter. Then you can see that the PySpark runs well, and then you can see this result is coming up in 4.24 seconds. So for the ratings data frame, I have these attributes. For movies, I have these attributes. And then for texts, I have these 4 attributes. So let me just check. Let me check the ratings data frame. This is a data frame. I'm just showing the top 5 data. So I have user ID, movie ID, ratings, and timestamp. For the movies, it has, I've run it already. So movie ID, title, and genres. And of course, text will show you another data, user ID, movie ID, text, and timestamp. Actually, we don't really need this timestamp column. Okay, so we check the data is well mounted and then well downloaded as a PySpark data frame. Now we can check the dimensions of data. So for each of the data sets, ratings, movies, and text, how many data is actually in it? Is it really 20 million rows, or is it really 465,000 rows? So this is the code to show you. And then it says that I have 20 million rows and 4 columns for ratings data, 27,003 columns of movies, and then 465,000 and then 4 columns of text, which is fine. Okay, and then what about the attributes? You can check the attributes here when you downloaded the data frame in this result format, but you can also just run a code and then check the attributes as well. Let me just quickly run this one and see. So ratings, you have a user ID in string type, and then the others are also string type. So my source data in Azure Data Lake Storage, it has all string type of data. So can I use this one for my analysis? So now I understand the data, but I still need to know if I can use it. So my ALS recommendation model actually cannot compute this string type of data. So I need to change them into at least numeric type. So this is the code that I am cleansing the data here. And I also don't need any timestamp here, for my analysis. So I'm going to drop that column. And when I run this one, now I can see that for the ratings, I have only integer, and double type of data. And of course, for the movie, I just changed the name to movie _df. And then it has 3 attributes. Now I'm losing the timestamp column, which is intended. And then I'll have all numeric type of data. So the data is ready to build the recommender system. So and then we can also check the data as well, the cleansed data. For example, for the ratings, I have this type of data. So ALS model, I'm not going to go into detail about the actual algorithm of ALS. You can just actually check it out from Visual BI website blog, or you can, of course, study by yourselves. But ALS model builds a user item metrics and refers to the ratings of the user to find their preference. In our case, like you can see here, the ratings data set provides all information of users, user ID, movie ID, and then the rating on that movie ID from that user ID. And then, so we'll just focus on this data set to develop our model. So this is what we have after I cleanse the data. And then now we are done to understand the data. You can, of course, plot some box plots or any other visualizations if you want, then we will see the results here in this cell. So let's build the ALS collaborative filtering model. And to build a model, the first thing you have to do is, of course, split the data set into train and test data sets. For my case, for those 20 million rows of data, I am splitting them into 70% and 30%. So my training data set is going to be about like 14 million. And the training data set, the test data set is about like 6 million. I use the random split function, the command here, so that you can, whenever you run it, you can you can have a little bit different numbers. But if you set the seed number, then it's going to be the same. So for the sake of time, I just ran it already. And it gives me that, the function gives me that my training data set is about 40 million, and then test data set has about like 6 million rows. So this is ready for the modeling part. And now the next step is to implement the ALS collaborative filtering function. So I'm going to use ALS command, which was given by ALS ML ALS recommendation module inside of PySpark. So I'm going to use that one. actually, this implementation includes some parameters that we need to adjust as a data scientist. So this is where the data scientist's knowledge and concept about the modeling is actually needed. So, for example, I set implicit preference as to false, which means since we are using the explicit feedback, which is rating on the movie from the user, in this case, I have to set this one as false. But if you're adopting implicit feedback like views, clicks, or purchases on that movie, then your model will better predict with the settings to implicit preferences to true. And then the other one, the cold start strategy, I set it as drop. This is to avoid any null values in the data set with cross-validation. It means the cold start is like when you don't have any data for the certain movie or a certain user. How do you start? How do you how do you predict the next level of ratings from one user to another movie? So I set it as drop. This is a simple implementation, but you can set another functions as well. And I'm going to run this one. Then it says that, okay, it's sending to cluster and it ran well in 0.14 seconds. So my Azure, my ALS collaborative filtering function is ready. And then the model, I'm going to model it with my training data set using the speed command and using this function that I built already. So it actually takes some time. If you can see this one, when I ran this one, it took about like 2 minutes. So I'm just going to use what I ran already for the prediction to save the time. So this one, the model built in the previous step was used to test the data. So this is the actual output that I got when I ran this model using my 6 million test data. And then this is the result. If you can see this one, I'm just showing you the top 10 values. So for user, let's say 69393, then it gives the ratings 3.1, actual rating 3.0 to movie 148. And then the prediction model actually gives the result that it's going to be about 2.7. So it's pretty fair. But you cannot really actually compare one by one. So how can we just evaluate the model as a whole? We can use this RMSE value, of course, root mean squared error value for the overall model. So my overall model RMSE value was 0.8, which is fairly okay. So I can just rely on this model. So let's just use this model to finally recommend the top 10 movies for the user. So this is a little bit longer code that I read. So I said, okay, I'm going to use that model, the prediction model. And then when I run this one for the user 96393, then this is what I got as a result. Okay, for this one, for this user, the prediction model recommends these 10 movies. Let me just see, a new life and then the prediction based on the prediction values. And then it seems like this person pretty much a kind of documentary type of person. So this model kind of feels what type of movies this user would like based on his previous purchase or previous viewing kind of history. So yeah, and then after this one is done, if the model is done, and you can schedule this whole notebook as a scheduling job. Let's say by using this one. So let's say I want to run this notebook every day. Then you can just set it run and every midnight, or you can just set a specific time. I want to do it every like 11 p.m. or 30 minutes, something like that. So, or 45. And then you can set up the time as well, Pacific or Central, whatever you want to do. And then if you click OK, then it's going to schedule a job. It means that this notebook is going to run every day at 11:45 p.m. So this is a kind of overall walkthrough of Azure Databricks to run a recommender system model. Chandler, I'm going to switch this one to your presentation.
Okay, thank you, Juan, for that walkthrough. So I think what you've just demonstrated for everyone is that there really is, multi-step implementation for data science, and with Azure Databricks, it seems to make it pretty straightforward to have everything in one place and be able to have a high level of collaboration. So if you're working with a team of people who may not even be in the same location, may be distributed around the globe, everyone can come together in the notebook and really see each other's work and be able to collaborate pretty effectively.
Right.
So just to kind of recap, I think what you just demonstrated is illustrated here on the slide, where you had a workspace that was launched. You were able to get the clusters configured, and again, clusters are an important part of this conversation, because that's really where the capability of compute and storage and making sure that you keep your costs low. So managing those clusters is pretty important in this process. And then you demonstrated the collaboration of the notebook. So you showed us how you can set up different steps and provide live code, as it were, as well as do some exploration of the data, which you're able to show us as well, and as well as building the data science models in the end to kind of really provide that prediction engine, if you will. And then lastly, of course, being able to schedule a job, which is I would imagine is pretty handy if you need to have a job run on a daily basis that's maybe going to require quite a bit of compute. You can run that so it doesn't interfere with maybe some of the other activities on the cluster.
Yeah, that's correct.
Okay, fantastic. So now we've gone through a lot of information on the webinar today around data science, and I just want to kind of mention that we at Visual BI, we do have offerings that focus in this space, and one of those is our Visual BI Modern Analytics offering, which really takes all the concepts that we presented this morning and allows our customers to really kind of fast track their own modern analytics programs and data science programs. So we can use it to harness data sourced from a variety of different networks, online networks, web pages, other types of unstructured data. We also have this offering that can help refine and tune machine learning models that will help boost prediction accuracy. And we can deliver a big data solution that can really encompass either a lift and shift implementation, or we can build a cloud native implementation using Azure Databricks, as Jawan just demonstrated. So really, Modern Analytics, this solution offering is really designed to help customers move beyond understanding what has happened to how they can achieve the best possible outcome. I think we are wrapped up for the day, for the webinar. I just want to say that, obviously modern data science, the projects, they require handling of substantial amounts of data to find those hidden insights. And Azure Databricks really is a way, a platform that provides cloud scale analytics at a fast and secured performance. And of course, Visual BI Solutions, we can provide end-to-end services for these types of implementations and provide end-user enablement of a data science solution. If you have questions and want to reach out to us, solutions@visualbi.com is the way to do that. And with the 3 minutes we have left for the webinar, we'll take questions here. So if we don't get to your question today, we will respond via mail, but why don't we go ahead and dive in. So the first question is, why doesn't Azure offer NC-V2, ND, and NV GPU instances for Databricks?
Azure Databricks, they have a GPU cluster to use if you need to do some big computation. So this one is more like a database type of data engineer type of question, but okay. Azure Databricks is still developing their interface and then their environment. So I think you can find some options for that, but they are offering some clustering options for GPU as well. So yeah, this can be actually we need to follow up Databricks as well. Yeah, so this is a very good question.
And clearly Microsoft has a roadmap around this, so that it might be worthy to take a look at the roadmap that Microsoft has published around Azure Databricks to kind of understand what capabilities they're looking to bring in the near future.
Someone asked me about in the deck data science resources in Azure. Databricks and Azure HDInsight is a storage platform, but Azure ML Studio and Azure ML Services are like services that needs the storage. And then somebody asked me to correct it. That's a very good and correct understanding. That's a good one. So that table, it was not actually it's not actually proper for the apple to apple comparison. But Azure Databricks is not just a storage platform. It can also have some kind of features to compute using Spark. So you can use it, but if you want to use ML service or any other integrated platform that you can use inside of Azure, probably you need the Databricks notebook to work on it. So yeah, I just want to mention that the understanding that Azure Databricks and HDInsight has storage is a storage platform. That's the correct one. And but also the Azure Databricks has some analytics features in it. And while ML Studio and ML Service is a service, and it needs some kind of storage or the compute engine for that.
Okay, very well. So I know we have a couple more questions, and unfortunately, I think we've run to the end of our webinar. So we will be responding directly back to those of you who posed questions on the IM board. So we will be responding back to you within the next couple of days. But I just want to thank Juwan for her time today and for taking us through the data science capabilities of Azure. With that, this concludes the webinar. Thank you again to all who participated, and have a great day.